Hi, good day, everyone. This is just the explanation for the session that we had the other day on Informal Free, just a feedback. This is basically just a summary of that session. So I'm just going to go through the steps whenever calculating the crash time and the reduction in time and the cost of that. So let's have a look at the question first. So please see the following table. The durations is in weeks, and then draw the arrow diagram and calculate the duration of the project. And then the second question is calculate the cost implications if the project was to be shortened by 4 weeks. Okay, so this is the first section of our question that we will have a look at. I'm not going to look at, in too much detail on actually plotting it, as it is very straightforward, and as mentioned, you do this in project management as well in more depth, where you actually do the forward pass and the backward pass. So just be mindful of that. I'll also just have a look. Our indirect cost is R1,000 per week, and our total cost is 110,000 at the start of the project. So usually when your indirect cost is a higher amount, the implication or the spin-off of shortening it becomes actually much more diluted or closer to each other. So if you have your direct cost a little bit higher, the implication of reducing your time and then your indirect costs will kind of or direct costs will balance each other out a little bit more. So just be mindful of that. So looking at the diagram, the main objective of this diagram is to establish the longest path, indirectly the critical path. So if any of these items takes longer, the project will take longer, but for our purposes we're looking at this to establish how long will the project take under normal circumstances. So if there is any reduction in time, this is the path that you want to reduce anything on, to actually reduce it, because after you've reached 3 weeks, you will, or 23 weeks, you might even have a look at reducing an item like E or so. So it does become a little bit more technical, but for our purposes we're just looking at the basic principle of reduction in time. So just be mindful that you can draw this. So in project management you go into this a little bit in more depth. So for our purposes, it's only to see what the cost implication is if we reduce the time. Okay, so looking at our items, we basically draw a little table, and we take what I did here is I just took our items and basically ranked them according to our cost slope. So the cost slope is basically the normal time and the crash time subtracted from each other. So if you've established your cost slopes, you can start ranking your items. So this is what we basically said or indicated here. So you will see here I also indicated that there's zero float on these items. If they fall behind, the project falls behind. So very important to note that. Okay, so what we've got here is all of this data on this side is given, normal time on this side, and the time saving is also given or calculated here. So for item A, we can save 1 week if we use our normal time, we subtract our crash time, so we can see, okay, we can save 1 week on this item. We can save 3 weeks on this item. Okay, and then we just basically calculate this, and we rank our items to the, and then we look at the lowest cost slope to establish our ranking. So we look at item B. So item B is the lowest ranked item because its cost slope is the lowest. So we rank that as our first one, and we can see item A has a ranking of 2, and then item I 3, 4, 5. And for test purposes, I would like you to please do the complete table, taking into account we're only asking for 4 weeks. So this is actually supposed to be 4. And so even if you look at items A and B, you only need these 2 items to get to 4 weeks in reduction. So you can actually have a look at that. And if you really want to get technical, you can have a look at, okay, now we're going into our other items, which is not necessarily on the critical path, and then one can actually rank them. But for our purposes, we'll have a look at just a basic calculation. You don't have to stress about that just yet. Okay, so basically what we've calculated now is we're reducing our project time with 4 weeks. So we know we've got 1 week where we're going to have a cost additional 3,000 Rand that we have to add to the project, and we're going to have 3 times 166.67 to be added to our project, and that is calculated at our variable costs at 8,000 Rand. And I think I've just cut off a section here where I actually just calculated that area, so, or that calculation of the total amount added. So it's 3,000 and then 3 times 1.66.67, which amounts to 5,000 Rand. So it's the 5,000 plus the 3,000 to give us 8,000. Okay, and then the reduction in our fixed cost is just 4 times 1,000. So there's a cost saving here. So you can see what the implication was. If this was, for instance, 3,000 Rand, we would have gotten a cost saving on the project. If it's reduced, so it would have amounted to 12,000 Rand of fixed cost savings that we could have put in here. And then what I've done here is I've just calculated the added amount and the reduced amount, and indicated that we've got a cost difference of 4,000 Rand, which is an addition to our 110,000 that we had here, and we get to 114,000. You can also use the steps that was shown in the book as well. So that is more or less how you do it. So if you do it systematically and you just draw the tables and add them together, then it's really straightforward to get to the conclusion. Okay, so that's the first section of question 1 and 2. Going to question 3, we look at calculate the optimum time reduction for the project and draw the accommodating graph. Okay, so here's a bit of interpretation that's needed. But in essence, you basically do the same as what you've done in the previous one. You use your items. So firstly, you start with your cost, what the project would cost if you had normal time. So at 26 weeks, we could calculate that we had a direct cost of 84,000 and indirect cost of 26,000 Rand. Okay, and then you can see our fixed cost is quite linear. The reduction as the project time is reduced, the cost goes down. Okay, and then our variable cost, what we do here is we take our items and we rank them as we would like to reduce each item with the least cost implication. So you would see our first ranked item is here, our second ranked item is A, and so forth. Okay, and then you basically just calculate what the aggregate in cost implication is for the project. Okay, you can do it on the project cost as well, to see what the cost implication on that is. It's exactly the same, does the same function, or gives the same function. You will look at a significant jump in any of these items, or in any one of the weeks in what you reduce the items with. So then if you look at reduction of 25 weeks, you can see, okay, there's a 666 rand that's added to the project by reducing it with 1 week, so that's still fairly fine. And then we've got another week of the same addition, and the third week we've got the same addition. And then we've got a addition of 2,000 rand here. Okay, so we can see there's a bit of a jump here, and we can see there's another 2,000 jump from week 22 to week 21, and then we've got another jump. It stays the same, and then we can see, okay, another 1,000 rand additional. Okay, and then we can see there's a 6,000 rand jump that we've got here. Okay, so whenever you're interpreting it, it is a bit subjective on the jump. So we've got a 2,000 jump here, we've got a 4,000 jump here, and here we've got basically the biggest jump of 6,000 rand. So for our purposes, if you can justify where the jump is, very important how the question was structured. In this case, my interpretation was it jumped from 666 to 2,000 rand here, so there was a significant jump here, which basically just was led by the graph as well. So I could see on the graph there was a bit of a jump in this section. So my interpretation was that the optimum time before that jump was 23 weeks. So that's the optimum time for the project if you do not want a significant jump in the project. You could have also interpreted the jump from here. You can see it's still fairly close to each other. And here we've got a 4,000 rand jump, and then 4,000, and then suddenly we jump to with a 5,000 rand. So you could have interpreted that you want to stop it at week 20. So if you could justify that by saying that there's a 4,000 or 5,000 rand jump now suddenly, instead of just a 1,400 rand jump that we had here, you're more than welcome to put that in, as long as you could justify it. That is also accepted. So the main thing is it really depends on project to project. I'm only going to test the theory of that and whether you actually understand that. Obviously, when you get onto a project, it's a bit subjective on the amount of money that's available, the amount that you prepared to pay more, the amount that the client is actually willing to pay more. So that is basically how to interpret that. Also note, you will see in this graph I worked from the left to the right. You're more than welcome to do it as per the book, from the right to the left. I only did this for Excel. Excel didn't allow me to actually make a graph from this side to this side. So that's just why mine is starting on the left hand side, working towards the right hand side. Okay, so, and then again the graph, you should be able to draw this. This is also very straightforward. If you've done the entire table, it's basically just plotting the items according to each week's difference. So Yeah, that is more or less in a nutshell how Informal um, Free looked. If there's any questions, you're more than welcome to contact me. Thanks, everyone. Keep well. Bye.